Good morning, Math 2 students. I'm going to show you very quickly a couple of examples that you see in your Delta Math assignment. I also want to remind you that this Delta Math assignment on probability is multiple types of probability, and we haven't gotten to the compound stuff yet. Today I'm just going to talk a little bit about some of the OR statements in your probability. So here's an example of a problem that I got off of Delta Math. It says in a certain Algebra 2 class of 26 students, 5 of them play basketball and 12 of them play baseball. There are 12 students who play neither sport. What is the probability that a student chosen randomly plays basketball or baseball? Now there's that word or. Whenever you see the word or, it means it could be basketball or it could be baseball, and either one of those sports would work just fine. So what I like to do is draw a Venn diagram. Now we have learned already last week that when we do basic probability, that the number in your sample space is your denominator. So in this particular class, there are 26 students. So when I do my probability, I'm going to have a denominator of 26 because that's how many kids in the class that I can choose from. Now, when I draw my Venn diagram, I basically have this giant rectangle here that all 26 students are going to have to be inside of my rectangle. This is kind of like the classroom. So this statement here that says that 12 students play neither sport, I just included those on the outside of these circles. So I'm going to have one circle that represents those that play basketball and one circle that represents baseball, and then these are the 12 that play neither sport. Now, if I just added up 5 that play basketball plus 12 that play baseball plus 12 that don't play a sport, that number is 3 over the number of students. Now, guys, that's how you figure out where your overlap is. Okay? So again, if there's 26 students total, 12 of them don't play a sport. So that leaves me with 14 students who actually play some sort of sport, whether it's basketball or baseball. But because 5 play basketball and 12 play baseball, that number is 17. There's only 14 students left. So when I subtract those, that is a difference of 3. 3 is the overlap. That means there are 3 students that play basketball and play baseball. So now all I have to do is just fill in the rest of this. 5 people play basketball. So if I've already got 3 accounted for, that means there's 2 left. Look in this basketball circle. Do you see that you have a total of 5 students that are playing basketball? Okay, I hope that you do. Now, since there are 12 students that play baseball, these 3 have already been accounted for. That means there's 9 students left. So if you look at our Venn diagram, we've got the 12 that don't play a sport. We've got the 5 that are in the basketball circle. They play basketball. We've got the 12 that play baseball. And if you add up these numbers, this is the total of 26. So I had to subtract from that total of 26 to kind of see what my overlap was. Now the question just wants to know, what is the probability that you choose a student at random and they play one of the sports? So when I do probability, my denominator is the total number of people I'm choosing from, so that's 26. And if I just add these guys up, the 5 that play basketball plus these 9 extra that play baseball that I haven't already counted yet, this is a total of 14 students. So if 14 out of 26 people play one of these sports, I can just reduce that fraction down to 7 over 14, and that's the answer that you will put in your Delta Math. 7 divided by 14 would be the answer. So you can set up a picture if you're a visual learner like me and you need to see it, but you don't have to, okay? Now I'm going to do another example of something that is on the Delta Math. Here it says that we have a spinner that has 13 different equal areas, and they're numbered 1 through 13. If the spinner is spun one time, what's the probability that the result is a multiple of 4 or a multiple of 3? That means your numerator can be either one of these, a multiple of 4 or a multiple of 3. So what I've done here is I've listed out the sample space. That spinner can land on a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or a 13. Any of those would work. So there's 13 spaces there. That's going to be your denominator of your fraction. Now, it tells us that we're looking for the probability of either being a multiple of 4 or being a multiple of 3. So this is what I'm going to do. I'm going to circle all my multiples of 4. So I've got the 4, the 8, and the 12. Those are the multiples of 4. So those answers will work. But I can also use the multiples of 3. So let's do that one as well. I've got 3, 6, 9, and 12. Now, I've already counted 12 one time, so I don't have to recount that one. So if you look at all of the different sections that we're using here, a 3, a 4, a 6, an 8, a 9, or a 12, those are the ones that are multiples of 3 and 4. So if I count those up, 1, 2, 3, 4, 5, 6, 6 out of the 13 are either a multiple of 3 or a multiple of 4, and that fraction's already reduced. So that would be your answer in your Delta Math assignment. Okay, tomorrow we are going to do some conditional probability. So as you try your Delta Math today, try the problems that are these OR problems and see if you can get through that section. And then tomorrow we will address the conditional probability. Okay, please don't hesitate to contact me, email me if you have any questions or any trouble. And remember, the great thing about these videos is that you can go back, you can pause, you can rewatch. So please do your very best and don't stress out. We still have a couple of more sections left of probability and then we are finished. All right, good luck, guys.